Hi everyone, thank you for joining us today for Supercharging Geospatial Analytics by Shanhi. We will begin shortly. Just a quick reminder, do not forget to share your best moments on social media about the GSC East Conference. Also, take our short survey at the end of the session. It will help us shape future conferences. Welcome our speaker. Shan, you can start.
Thank you. Hi, everyone. My name is Shan. I'm a director of engineer at Foursquare. My background is in geospatial visualization analytics, and I have been building tools and platform for geospatial data for the entirety of my career. Today, I will be giving you a demo of the geospatial analytic platform I have built for visualizing, analyzing large-scale geospatial data in browser. So Foursquare is a location data platform, and we are building product and an analytic product that help people harness the value inside their location data. So location data science to me has mainly focusing on the data that about humans move and how humans move and resides in the built environment. It has changed from our traditional understanding of geospatial data, where it's to a new dimension that frankly a lot of challenging for understanding these large scale of geospatial data. So the platform we built is called Unfolded. It's a geospatial analytic platform for big geospatial data analytics and seamlessly spatial temporal unification. We're set out to conquer some big challenge that the location data industry has faced, mainly because the data we collected through our phones are multi-terabytes of data sets every day. And it's always planetary scale. It always has a time dimension to it, so adds more complexity to the data itself. And it's because of the different methods we use to collect this data, we always encounter data within different formats. So if you have attended my colleague Nick's talk, you will probably have a little introduction to the spatial indexing system that the whole Unfolded methodologies is built on top of. We are using a H3-based hexagonal grid to unifying data from many different formats, no matter it is satellite imagery or geo-admin boundaries or telemetric data that has latitude, longitude, and the time. We were able to unify all in this one format where in our pipeline, we can convert data from into this H3-based unifying grid. Once you're able to convert data from different format into one unified grid, you will be able to draw many different analysis like causal relationship, outlier detection, cluster and class and anomaly detection, or running machine learning models on top of this unified data sets. So yeah, with further ado, so today I will be demoing using one of our web-based application called Unfolded Studio. It allows clients exploration of large-scale geospatial data. It is built specifically for looking into location data that tracks movement and time. It is built with many different presets, visualization that help you supercharge your analytics on your location data. It collects many different data formats, supports planetary data sets such as satellite imagery and telemetric data. Yeah, it has many different operation built in and can animating out of the box animating trajectory data that records tracking data sets or playing any transportation data sets we have. So these are some of the visualization product I created using our platform. specifically for different type of geospatial analytics. And in the end, the platform is built on top of the proprietary data format that Unfolded has created called Hextile. Nick has given a little bit of introduction how we can use H3 to convert planetary data sets into these hexagon-based tiling system. Each of the cells we can use to record different metrics, so we can use this analytic type of tiling to enrich, unify with our own data sets. So yeah, let's with further ado, let's go into our demos. The first one I will be showing is looking at a large data set of all the rivers in China, and then joining with our Hextile data set that has the global elevation in it. The idea is because for me, I like to do some painting. I want to paint all these river lines with a different color based on their elevation. And usually this type of operation might be pretty heavy into using the traditional GIS tools. But with our Unfolded Studio, we can do it pretty easily in the browser. So to test it out, let's go to studio.unfolded.ai. Once you get here, after signing, you will see here you have we have many examples of how to use this platform to create awesome analytics, geospatial analytics and visualizations. It's a SaaS platform, so you have place to see all the maps that you created. If you are sign up as teams, you can see the other maps that your teammates share with you. And we also have a data catalog where many of the data sets we have built and can be served as a Excel format. On our catalog, we have census data sets, global elevation data set built from the digital elevation database. We also have data sets of American infrastructure, remote sensing data set, including Sentinel and Landsat. And we are growing this list of data catalog and as we speak, so stay tuned to see more things coming. And let's go back to the demo. So if you click create a new map, this will take you to a new map session inside Unfolded Studio. And you can load your data set, either drag and drop for your browser or looking at the other data set you previously loaded into our cloud. So I will load a data set called rivers. This is a data set I grabbed from the OSM and filtered down to only rivers in China. You can see once the data is loaded, it automatically shows up as a data layer. Here are 200,000 of lines of rivers that's in China. And the next step is I will add my elevation data sets from the data catalog. So inside here, let's pick the elevation absolute and go add data. Loads pretty smoothly. I disable the tooltip just so. As you can see, with the Hextile, this is a data set that we're serving to the Hextile format. With the Hextile format is a different zoom level. We can load data with a higher grid or fine grid of aggregation. So we can get down to a 100 meters of radius, or as you zoom out, it shows you aggregated data as a higher aggregation level. So let's move our reverse geometry to the top. So this is our starting point. We have the data showing the elevation of the entire globe. We also have our reverse data set. The next thing I want to do is to join our reverse data set with the elevation data set. Now I have to do some processing because we joins data currently only supporting joining data with points. So I read a little script to break down this line stream geometry into individual points. And let's load it in. And you can see in this data set, we have a lat long for each river, for each point, and then the ID, OSM ID for the geometry. So it looks pretty good. It's every single points that we have for these rivers. And we have about 1 million points right now loaded in the browser. So let me clean up a little bit. Let's turn off our hexel layer and turn off our turn-offs of lines, looking at only the points, and start joining. We want to join this points data set with our elevation data set in here. And it's asking us to put in either H3 or a lat long column. So we do lat long. And then there we go. We have the points data set on the left. We want to do a left join with the elevation data set on the right. And then we click run. Because we have about 1 million points, this joining is gonna take about a minute to do. So let's start our timer for about a minute, and we can go into. At the meantime, I can show you some other hexel data set that we have. So this is a data set that we built from the census 2020 census. We break down the census block group into unified H3 cells, and then at different level, we embed this analytics into each cell, so you can see the this total population and total housing in this cell. We can also show data at different resolutions. So this is looking at population at the entire U.S., or you can zoom into just the DC area and see how the population break down into a smaller grain. All right, so that's about time. Let's go back to our river demo. Let's give it a couple of minutes. There we go. So after the join, you can see we now have a fourth column in our point data set with the max elevation in it. So let's do confirm. Automatically, a layer will be added after we join. We can see in the data panel, now we have a joint data set. Let's rename with points with elevation. And that's pretty much it. So we have automatically it's painted by the elevation column. And now we have all the river points based on elevation. We can start doing some geometry construction because our original data set is line stream. We want to convert this point data set into actual line layer. So let's just switch this points into a polygon layer. So in our polygon layer, we actually can reconstruct lines from grouping points based on a ID. So you can see now we have the geometry constructed by just associate points with IDs. And let's go back to paint our line stream with the elevation column. So we assign stroke color to our max elevation column and then change the color to be more elevation looking. So we can do let's do a step, a more fine grained step, and then use this color palette. There it is. So now we have a line layer that's painted by the elevation of where this river runs in. And if you know China, this is the higher elevations where Tibet is. And these couple of holes here are, deserts in Xinjiang. This is 2 basins in Xinjiang. I forgot the name off the top of my head. And since the goal of this is looking for highest river, we can start filter down our rivers based on the elevation column we just joined them by. Let's create a filter and then create based on mask elevation. Let's see, we're only looking at rivers about 3,000 meters. We put in 3,000. There we go. So now we're looking at only rivers, floating above 3,000 meters in altitude. We can export the result of these as a CSV. We can select the points with elevation and then do filter data. And once we do export, we will be only looking at data that rivers are running above 3,000 meters. All right, so that's my first demo. The second one, I will be showing a little bit of things we're doing day to day. The second demo, I will be showing some housing data when we're all trying to buy a house. This one, I was trying to look for a real estate listing for my friend Maggie. She wants a place that's close to bus stops, close to schools, and close to restaurants. And I took the liberty of collecting some data set from Denver in Redfin. I put in all this real estate listing in my map, and then we have 6,000 homes. So that's a good starting point. Let's see if Maggie wants something close to bus stop. We can add a data set, Excel data set my colleague built, travel time. Let's say we can load a Excel called time to school. We load another one called time to bus stops, time to restaurant, and then add them all to our maps. Now this is gonna load quite a lot, so let's clean up a little bit. Let's hide our homes for now, and then only looking at time to school. So, and then probably bring up our road layers just so that we can see where we are. So we have this time to school travel time map. Each of the cells is showing the minutes that the driving minutes that it takes to the closest school. Now this hex chart is built on top of the Foursquare POI data showing where all the schools are. Since this data is way too big, we can start by extracting into just the areas that we care about. We can start drawing a square in Denver, and then we can do extract data. We only want data set from this time to school, doing confirm. Let's name this to Denver time to school, extract. Okay, now we have a smaller set of data to work with. So let's delete our other layers, only looking at this time to school. And because Maggie also cares about time to restaurant, time to, time to bus stops, let's joining this our time to school with the time to restaurant Excel. Name this column to time to school, calling the other one to time to restaurant, and then selecting the H3 column to join based on, and then hit run. There we go. We have now we joined our time to restaurant with time to school. Let's do this operation again to join with time to bus stop. So let's do another join on this. Same audio, we select time to bus stop, and we rename this column to bus stops. And then select the H3 here, we do run. We have unified 3 different travel time data into one based on this hexagon resolution 9. Let's do confirm. So this is the final data set we want to work with. Let's call it where to buy, and then change the color to something that's easier to find. Okay, so we have the layer where to joining based on where to buy. And let's turn off this color and start playing around with it. Since we have everything joined into one unified shape, we can start applying filter to it. To apply filter to time to school, have another filter to time to restaurant, another filter to time to bus stop, and start working. So this is looking at everything. Now Maggie wants something that close within 5 minutes drive distance to bus stops. Another was 5 minutes drive distance to restaurants and 5 minutes drive distance to schools. There we go. Immediately, we filtered down to the areas that only within 5 minutes drive to all 3 different facilities. So we should go to tell Maggie, here's where you should go search for. And that's not good enough because Maggie is not technical as we are. She will still be looking at this 6,000 homes saying, how am I supposed to filter it down? So we can do it in our tool by filter these homes based on, this, let's call it region to buy. Before we do that, we want to extract our filtered region to its own data set. Let's do extract. Here we can say we want all the columns, and we specifically want filtered because we want to only looking at the regions that filtered by our travel distance. Let's do extracting it, and then we're asking if you want to replacing the existing one. We say yes. Okay, so let's turn off the other layers here. So now we break down this extract where to buy, and this data set will only contains the filtered hexagons that are based on our travel time under 5 minutes. And let's join it with our homes. So we can do it by first selecting our homes data set. We want to join by H3, so we need to create a column. Let's call it H3 hex 9. And let's use the expression by expression geo to H3 based on our lat long column. And we want the resolution 9. So now we added a H3 column to our homes data set, and we can start joining. We can say we want to join our homes data sets with our where to buy, extracted where to buy. I want to join based on a hexagon column. I want to do an inner join to run. So now we have the homes that joined with our travel time. And because we did the inner join, we're only showing that with homes that has within the travel time hexagon. So so let's change this layer to be a point, and then using our address column. So let's hide this one. Okay, so now we're looking at homes that only within our travel region. So these are filtered down homes. Let's see how many we have right now. We have still have 1,000 homes that for her to look for. And the last thing, then we should start it to keep filter down, because Maggie says she wants at least 3-bedroom. She wants, she has a price in mind about 1 million. So we do, this is detected wrong. So let's do a square footage. She wants at least 3,000 square footage. Okay, so we filtered down to about 300 homes. I think this is a good enough starting point for Maggie. We can export this data set saying, I want to get this final result of 300 and then exporting it. So now we have 300 candidates for Maggie. Each of them has, we also connected how long it takes to drive to these facilities. I think we're at a good place to tell our friend Maggie that, go look for on this list. So that's all my demos. And I want to mention that even though today my demo is running in our browser tool, we do also have integrations of Portfolio Studio in many different data science platforms. We have integration with Jupyter, Google Colab, Databricks, Amazon SageMaker. You can load Portfolio Studio inside these tools, and then so you don't have to jump around tools to interact with maps. So yeah, that's my demo today. And thank you for coming. I know I went through a lot of different steps, but there's plenty of materials for the studio website for you to look into how to recreate this analytics, and many different interesting maps on it as well. So feel free to go ahead and take a look and start making maps. Yeah, that's it.
Thanks a lot. It was a really an amazing session and insights. We do have questions from our attendees. So first one from the Himanshu. Can we apply a filter on properties of markers? Each marker has 500 properties, and ideally I would like to search for a property and use filter option to see only the points which have that particular property.
Yeah, so yes, you can definitely, like, these are the things I just demoed. The reason I can apply filters to these columns is because in your table you have, like, for example, you have, these properties, and every single column we allow you to apply filter based on. Depends on the type of column in here, you will have different way of filter them. If it's numbers, you have this little slider. But if you say you have a filter that's, let's say, a string addresses, then you can start typing, searching for addresses, and filter them down.
Yeah, thanks a lot. Another question, is it possible to combine two choroplasts data to update the intensity in the same GeoJSON data?
To choroplast intensity. So the layers we designed are, so you're probably looking at choroplast using our polygon layer, and you will need to use so you can create color of this chloroplast based on a column. So you can create a combined expression. Let's say, if you want to combine the number of beds and number of bathroom, you can create a matrix and combine these two columns, and maybe just do a silly one, let's say combined, and then do, maybe however you want to write your expression for. And you can create a third matrix by combining these two, and then have the color of your chloroplast based on the combined column. I hope that answers your questions.
Yeah, I hope so. Yeah, we do not have any other questions. Yeah, if anyone will have anything or have any feedback, please type in the our channel on liveodyssey.com. I'm sure that Shan can stay a bit longer. Yeah, if some the answer, yeah, they are thanking for answering the questions. Thank you so much for joining us today. It was a pleasure to have you, Shanhi. We are really grateful to our audience. Thanks a lot for the questions. Please do not forget to take our survey at the end of the session. It will help us shape future conferences. Also, please share your best moments on social media, and enjoy the rest of ODSC conference today. Thank you a lot. Bye.
Bye.